Welcome! Today we are going to learn about integration, the sine function raised to an even power. So we're going to begin with the example in item 1 to demonstrate this. If you notice, we're integrating sine to the fourth power. In item 2, we're going to split that up into sine squared squared. The idea here is to have sine squared raised to some power. And the reason we're doing that is because in item 3, you're going to see we're going to replace sine squared with a trig identity. The trig identity we're using here, and again, you can look this up, for sine squared is 1 minus cosine of 2 theta over 2. In item 4, we just bring out the constants. It's always a good idea when you integrate. If you have any constants, bring them in front of the integral sign. It simplifies everything, and then it's an easier process to integrate. So remember, our denominator was a 2, but then we were squaring it, so it's actually 1/4 that we are going to bring in front of our integral sign. So let's continue. Item 1 is the function that we just finished with. In item 2, we have, we're going to actually replace, or I should say expand, 1 minus cosine of 2 theta squared. I want you to think of it just as a simple binomial squared, and in the way that you're going to process this. What do? Is you square the first term, and we have that as 1. Then you multiply the two terms together and double it, and that turns out to be minus 2 cosine of 2 theta. And then last, we square our second term, and that becomes plus cosine squared of 2 theta. And you can see all that in item 2. In item 3, the only thing that we have changed is we have replaced cosine squared of 2 theta with another trig identity. Again, the idea here is we want to get rid of any terms that are squared or raised to some power before we integrate, because obviously that's an easier integral. So we're going to use this identity, 1 plus cosine of 4 theta over 2. Remember, it's cosine of double whatever the angle is. Since we have 2 theta here, when we double it, it becomes 4 theta. And then in item 4, all we're going to do is split up all the integrals. Remember, when you add or subtract terms, they can be separated out into individual integrals. So our first term was 1, but remember that d theta gets carried along with every term, so it becomes simply the integral, 1/4 integral of d theta. And by the way, don't forget that 1/4 gets distributed to every term. The second term is minus 2, but when you multiply by 1/4, it's minus 2/4 times the integral of cosine of 2 theta d theta. Our last term, which in item 3 is 1 plus cosine of 4 theta over 2, well, that can be split up into 2 terms because remember, 2 is a common denominator to both terms in the numerator. So we really have 1/2 plus cosine of 4 theta over 2. So the 1/2, we're going to integrate that. But again, remember, we multiplied everything by 1/4, so it now becomes 1/8 times the integral of d theta, and that's in item C. And then the last item in D, well, we had cosine of 4 theta over 2, but then we multiply that by the 1/4, so it's now 1/8 times the integral of cosine of 4 theta d theta. Now I've repeated what we just did in item 1, and then we're going to actually integrate at this point. And you know, we actually get to do the fun stuff now. Up to now, we've done a lot of substitution and simplification, but the whole idea here was to get integrals that were fairly basic to integrate. The integrals before were obviously a lot more complex. Now, let's take it a term at a time. So if you look at the term in item A, when we integrate d theta, we just simply get theta. And we're multiplying, of course, by 1/4. In item B, well, the integral of cosine is sine, so it's the sine of 2 theta, but since it's in item B, it's cosine of 2 theta and not theta, you have to take the reciprocal of that, which is 1/2, and bring that out front, and so it becomes 1/2 times 1/2, or 1/4. A formal method, use substitution to do this. I do have separate videos, and if you want to see that, feel free to watch that video to understand exactly that process. But an easy way to do it is just whatever that if angle is, if it's 2 theta, then you just take 1/2 and bring that out front. Then item C, when we integrate d theta, we get theta times 1/8. And then item D, again, the integral of cosine is sine, so it's sine 4 theta, but since it's 4 theta, we need to bring out a 1/4 and multiply that by 8, so it becomes 1/32. In item 3, the only thing we did was we combined two of the terms. The terms A and C were the same, were both theta, so we can just add them together and we get 3/8 theta. And everything else pretty much stays the same. And that is our answer. So that's how to integrate the sine function raised to an even power. Now practice, practice, and practice some more.